right, welcome back from intermission, folks. Hopefully folks gave that a shot. Okay, let's go over a couple different ways we could approach this problem. All right, let me set up this boilerplate. One way we can represent this is with a for loop that goes through the range of 2 to 100. You can represent that range with these three expressions here. The initializer, we'd have to start it at 2, and then the condition, we'd have to say keep doing it until we're underneath the upper bound, 100. That's the upper bound. And then the incrementer, this is changing the variable. So some folks might have increased the number by 2 for every time. Some might have increased it by 1. Either way is gonna work. Let's do a for loop here. So I'll write a for loop. Let me set it up. So there's the parentheses. We need 3 things in here that represent the range from 2 to 100. So I'll probably go ahead and initialize a variable. I'll call it I. I'll initialize it 2. And then the condition needs to represent how often we do the loop, or when we do the loop. So we should do it when we're underneath 100. We're underneath or equal to 100. I put the equal sign here so we can include. All right. And semicolon here. Okay. So real quick, before I move on to the incrementer, I just want to point out that the incrementer doesn't happen after the condition. Like some people might think it goes condition and then increment, but that's not the flow in the for loop. The incrementer actually happens last. So after the condition, we do the statements and then finally increment. All right, this is one of the biggest takeaways from today. Increment is the last thing that happens in a loop. So we'll increment something and then check the condition. All right. So I'm not going to write the incrementer yet. Let's just so folks understand the flow of a for loop. Let's go ahead and do the statements, and then we'll do the incrementer last. All right, this way people will see what might happen. Okay, so let's say the statements here is attempting to increment a sum or accumulate a sum. Well, first we'd have to keep track of a sum. So outside of the while loop, I'm going to declare a sum variable. The reason why I declared it outside of the for loop is so it lives through the whole program. If I were to declare the sum inside of the for loop, the scope, we're in a local scope, these curly braces, meaning the lifetime of this variable will only last in the scope. Okay, and it's going to refresh. It's going to be reset to 0 every single time. So it's necessary to initialize it 0 outside. All right, so let me go ahead and accumulate the sum. So within every iteration, sum is going to get bigger by I. I is the counter variable. I is going to go 2, 4, 6, hopefully. But let's see what's going to happen. So let me do a print statement real quick, just to see what's going to happen. This is a possible exam question, by the way, folks. But the exam question might say, what is the behavior of this loop? So yeah, go ahead and think about it. What do you think the behavior of this loop is going to be? Feel free to pause the video and see what might happen. All right, let me go ahead and run it though. For loop warmup.java. Okay, people see what's happening here. We have an infinite loop. It's never going to stop. All right, so do people see why this is happening? So the control flow of this, well, the initializer only happens once. And then next we check if this is true. Yeah, 2 is less than 100. So then we're going to we're going to accumulate sum and then print it out. Right? But then there's no incrementer here. I never changes. So when we check the condition, this is still going to be true. I is always 2 and it never changes. All right, so that's why we have the incrementer. It helps the condition stop at some point. Okay, let me quit this program. Control C, there it is. All right, so it might be necessary to increase by 2 every time. This incrementer happens last once again. So it goes initializer once, checks the condition. If it's true, we'll do the statements, and then we'll increment. Right, and then we'll loop back to checking the condition again. So now the behavior of the loop is finite. It's finite. If you want to sanity check it, we see the first iteration is 2, and then we add 4, becomes 6, add 6, becomes 12, and then so on. So then we have 2550 at the very end, which should be right. All right. Cool, cool. So let's talk about an alternative solution that's slightly less efficient. It's also possible to increment by 1 instead of 2. If I were to increment I by 1, first of all, we're going to get an overestimated answer. It's no longer 2550. Now we have like double, like 5,000 something. So this is an incorrect solution because we're adding the odd numbers. We're adding 1 plus 2 plus 3 all the way to 100. Our goal was to only do the even numbers. So if you were to do this method here, increase by 1, you'd have to find a way to protect this accumulation step. You'd have to find a way to say only accumulate I if it's even. All right, so how would we do that? How would we protect this accumulation step? We need to find some way of saying it's even. So imagine if we had like an if statement here. Imagine if we had an if statement that attempted to say, if I is even, then accumulate it. All right, what would go in the parentheses? How do we test if something's even? You might remember the modulus operator. Like, is 5 even? 5 is not even, because if we divide it by 2, it gives us a remainder of 1. Remember the modulus? This does gets the remainder from division. Okay, and then a 6, is this an even number? Yes, it is, because the remainder is 0. All right, so you could check any number you want. You can see, is this an even number? No, it is not an even number because it has a remainder of 1. All right, so we could say if I is even. Okay, don't forget these 2 equal signs here. Oh, I meant 0 here. So this condition is saying if the remainder is 0, then it's even. So then we're going to accumulate it. All right, so let me go ahead and save this and test it now. So yeah, now we get the correct number. 2550. Okay, I hope that makes sense so far, folks. Okay, any questions about this? Okay. Well, let's move on then. I'm gonna let folks try out this next one themselves. It's a good idea to try it out. A good use of lab time would be kind of translating between while loops and for loops. They're vice versa. You can always rewrite a while loop into a for loop, and vice versa. Yeah, please try this out yourself. Let's see. Okay, so that's it for this class exercise. There are a lot more that I would like to encourage folks to try out as well. If you could try out as many problems as you could in the first few sections in chapter 2, that would be great. It's a good use of lab time, and it's likely you'll see the same questions on the exam. So the chapter here, 2.1, 2.2, 2.3. I'm gonna look at 2.3 real quick. So 2.3 over here. There are a bunch of practice problems. In particular, this one over here. Let me scroll down. Yeah, so there's this other practice problem here. It's called counting. The goal of this program is to read an integer from the user. So if we read the integer from the user, this would represent the upper bound, and next the program should print all the numbers up to that. So for example, let's say I finish writing the program and I run it. say we type in 4. So this is red because it's representing input. So if I type in 4, the program should loop and print out all the numbers below 4. All right, and here's another example. If I run the program again, type in 1, it should print out 0 and 1. So I highly recommend folks try all of these programming exercises. It's really good for practicing. So I'll do this one, and folks can try out the next ones. It's probably a good idea to organize these exercises like in a directory. Our examples folder is getting quite large, so I would probably create like another folder. You can create a folder over here. I would probably create another folder and call it practice problems, and put the file in there. This way things are more organized. So I'll go ahead and do that. I'll call this counting.java. There it is. So here's a exercise. I would probably comment this as well. This way in the future you know where this problem originated from. So I'm going to say this is 2.3. Maybe I'll give it a link as well. 2.3 and then counting. I'll just link it over here. So okay, counting exercise. Yeah, this is a practice problem. All right, so let's go ahead and attempt this. So we need to first read an integer from the user. Note that this is silent input, by the way. Silent input means there's no prompt to the user. It means that when you run the program, the user doesn't see anything. They just have to type in a number and then press enter. So that's called silent input. Let's go ahead and do that. So I'll go ahead and set up the scanner. I'm going to use a scanner here because it's more powerful. So I'm going to declare a scanner object, and I'm going to set it equal to, set it equal to a new scanner that's going to work with the keyboard. System.in is kind of like saying we're going to scan the keyboard. It's just a standard input. Standard input for us is keyboard right now. In the future, we're going to be scanning files. When we do data analysis, it's going to be necessary to scan files and kind of predict things based off of it. Okay, so let me set up the inputs, and we are going to have to read an integer from the user. So I'm going to take advantage of the scanner method. There's a scanner method that helps us get integers over here. Integers, yeah. So there's this scanner method. It returns an integer after it scans the next token. So the next token is like something we type into the keyboard. All right, so let me take advantage of that. Inputs.nextInt. Okay, so this is a method. It returns an integer, by the way. It has a return value integer, meaning it's probably going to be useful to store it. I'm going to store it because we're planning on using it as an upper bound in a loop. So I'll store it as a variable called upper bound. Okay, and real quick, let me sanity check this just to make sure that the program is capturing the number correctly. Okay, this is just a sanity check. I'm going to delete it right after this. Okay, let me test it. Java. Oh, you know what? I'm in the wrong directory, by the way. I'm in the examples directory. I did create a separate folder, a separate inner folder called practice problems. So let me navigate to that. So cd into practice problems underscore problems. I put an underscore in there, so I treat it as one word. Okay, there it is. And if I do ls, I should see it. Counting, yeah. Okay, let me run it. Java counting.java. Great. So this is silent input right now. I just compiled, and now it's running the program. So it looks like it's frozen, but it's not. It's waiting for input. So if I type in 4 and enter, the program will finish. And yeah, the sanity check. It looks like it's taking the number in correctly. So we can go ahead and continue the rest of the program. Let me check out this practice problem again. Okay, cool. So we handled this first part, read an integer from the user. Now we have to find a way to print out all of the numbers underneath that integer. So I recommend pausing the video and trying this out yourself, just because there's like a lot of room for creative exploration. You can do this in a while loop, you can do this on a for loop. There's tons of variations of loops you can do. All right, so feel free to pause it and try it out. I would probably recommend a for loop because it's going to look cleaner. In particular, the for loop is going to represent the range from 0 all the way to the upper bound. Meaning that I would have to initialize some variable to 0 and then say stop at the upper bound. So I'm going to say I is less than the upper bound, or less than or equal to. Equal to, because I want to include that number. Right, and then let me go ahead and increment I equals I plus 1. Okay, and then now all we have to do is print it, right? Because I is a number that goes from 0 all the way to the upper bound. So we can just go ahead and print it plainly. I'll print it as with an end line, so print line, and then I'll just print out I. That's all you have to print out. Okay, let me go ahead and test this. So Java counting, and then okay, it's waiting for input silently. So I'll type in 4, enter, and cool. Looks like it printed all the numbers below 4, all of the positive. So 0, 1, 2, 3, 4. All right, let's test it again. See, here's another sample test case that the problem gives us. It says if we type in 1, we should get 0, 1. So let's try it. Okay. Okay, let's press 1, enter, and 0, 1. Cool. It looks like our program is behaving fine. We can test more if you want. Like if I type in 100, enter, now it gives me all of the numbers below 100. All right, see 100 and then all of this stuff here. Okay, cool. So this was a practice problem here. I recommend trying them all out. They get harder and harder, but it's good exercises. It'll help reinforce this loops. This is important stuff, especially for next week, because we're gonna be applying loops to common algorithms and real life scenarios. So it's by next week, make sure you're kind of comfortable with the basic syntax of these two different loops. All right. So yeah, the prerequisite is pretty much just trying out all the exercises in these supplementary material. All right. So yeah, feel free to let me know in the discussion forum if anyone's having trouble with any of these programming exercises. I'd be happy to go over a sample solution. All right, there's a, yeah, just let me know. Okay, let's see. So yeah, that's it for today. We covered, that's it for this week. We covered while loops, for loops. We did a bunch of exercises. I'm gonna record a separate video later for hints on the next programming project. So stay tuned. It's gonna be like a 15-minute video. Okay, thank you all, and yeah, have a good day, folks.